this video, we will look at using the serial object to output text and numbers to the serial monitor. We will also look at creating some custom functions and to get a feel for how those work. And you'll also learn about for loops and some basic logic that can be useful in your programming endeavors. So let's get started. I've created a new file using the File New Sketch option. And as we discussed in the last video, the file template comes with two functions: setup, that's called a single time, and a good place to initialize variables and those types of things, and then a loop function that is called repeatedly once the setup function hands off to it. So to begin, let's create an object, a serial object, and we'll write to the screen. In the last video, we learned how to call some built-in functions to do some interesting things like set the pins of the microcontroller for input or output and to write to those pins. And here we will use this object that's a part of the Arduino and Teensy ecosystem to write to the serial monitor. And to start with, we will type the name of the object, serial, and which again is a object that's just available. It's part of the installation. And this object has a number of functions, or they're sometimes called methods when we're talking about an object, as we are with the serial, that can be called. And we will be using this one called begin, which takes a long integer. And we'll use the number 9600. That's the baud rate that will be used, and then follow that by a semicolon. So what we just did here is to tell the serial object, which you can really think of like a global object that's available to your sketches. The dot tells us that we're going to call one of the many built-in functions, in this case begin, and then we send a number to that begin function to tell it the speed of which we'll be communicating with the serial monitor. The next step to get some output is we'll call another function of serial, print or println, which println prints a line and puts a carriage return after whatever you're outputting, and that's when we'll use. And at this point, create our parentheses and a semicolon. We could output a number, or in this case some text, which is a common phrase when you're getting started with programming, is to write a hello world output. And here, just notice that in the C and C++ language, we're using quotes for text. So whenever you have strings or text that you want to work with, we would enclose those in quotes. So I'll go up to the top right of the Arduino IDE and open the serial monitor. We will upload that code to the Teensy. Happens to be an LC in this case. It's done compiling, and our microcontroller just communicated a message to us, which I think is pretty cool. Another example, something that would be useful to learn, is the concept of a for loop. Loops are used in all programming languages, at least to my knowledge, and they're very important for a wide variety of things. The syntax does look a bit awkward, but they are not unduly difficult and will soon be very easy for you to use these with a little bit of practice. So the syntax looks like this in C. We start with the for keyword, then opening parenthesis, and now we're going to initialize a variable. So int, and then the name of that integer can be anything you want, but it's common to see words like counter or even a single letter. I is very common, so that's what I'll use. I equals 0. Notice it's very important that you initialize variables when you are using them in this way, such as with the counter. It's without that initialization step, the value of I may well be 0, but it occasionally might be a random number. And those are very difficult bugs to track. So just get in the habit of when you create an instance of a variable, go ahead and assign it. Now we use a semicolon, and then we give it the range that we're interested in. So in this case, this will loop as long as I is less than, let's say, 10, as an example. Another semicolon, and then now the counting part of the loop. And a shorthand is to use plus plus if you want to count up by 1. So I plus plus means that every loop, it will just increase I by 1. And now we have our opening and closing brackets. And that would now count from 0 to 9. And let's see if that's actually true by printing that output to the serial console, serial monitor. So here we go, serial print. And to make this fancy, let's go ahead and add some text. We'll say I equals, so that will not create a carriage return. It's just going to print this text. And then let's add one more, print line, and we'll add the actual value of I. And what you should see in the serial window, which I'll clear out, we'll compile, and then here you see that I is equal to 0, 1, 2, 3, 4, and so on. Another thing that would be helpful to cover, that's an important part of programming, are the use of functions. So in the last video, you learned how to call functions that enabled the configuration of pins on a microcontroller or setting the output status of the microcontroller. In this case, we're going to write our own simple function to square a number. Now granted, this is doesn't really warrant its own function, but I think it will be helpful in illustrating, one, how easy it is to write a useful function, but also the syntax that's involved. So with functions, we either use the void keyword if it doesn't return a value, or we use the data type and put that before the function name. So since this function will return an actual calculated value, I'm going to use the long keyword, meaning that this function will return a long integer. I will elect to call this function square it, and then within the parentheses, I'd like to be able to receive an integer to this function. And I'll just call the integer n for number. But again, you could call it anything you want. Put our brackets. And now we'll do a little simple math that will square that number. So the long-winded way of doing this would be to create another long integer. Let's call it sum. It's more appropriately product equals n times n. And now we use the return keyword to return that value. So if we go back up to the setup function, and of course I'm doing this in setup because I don't want it called repeatedly. We're just wanting to run this a single time. We could ask for that value. Let's start by creating a variable. And now we can call our newly created function and send it a value. Let's see what the square of 10 is and see if our logic is working appropriately or properly. Here we go. And let's output that value so we can see it. And upload the code. And the expected 100 is returned. So to just review, this very simple function has a name. We gave it a unique name, square it. It shows us that it will return a value, and it takes one integer as a parameter. That parameter is handed off to the function, and we calculate a result in this product and then return that. I do want to point out that less clear but quicker way to do that same thing would be to just use the return keyword and then just square it and send that back. And so let's go ahead and try that. Uploading the code. And there we have it, the same result, in this case, 100. And the last thing to review is how simple it is to then call that function. We just create a long integer in this case to receive that value, call the function, and then send a parameter to it. And just to demonstrate, let's see what the square of 48 is. And there we go, 2304. So those are a few tips on getting started with being able to identify functions and see how they work, but more importantly, start to write your own. Let's create a more interesting function, one that will enable us to track the sum of an arbitrary range of numbers. And for this, I will start with the long keyword again, and it will, let's call it find sum, and this will take two parameters, an integer, let's call it the low integer, and another integer, the high integer. So for the body of this function, we will start by creating a long integer called sum to store the sum. And now we'll use a simple for loop to iterate through that range. So we'll start with an integer, let's call it I, and set that equal to the low parameter. And then as long as I is less than or equal to the high value, we will increase I by 1 on each iteration of the loop. And now it's a simple matter of saying sum equals sum plus I. And by the way, a shorthand for that is sum plus equals I. In any case, now we've calculated the sum, we can return the value. And to try that out, let's create up in the setup a variable, and let's call it sum range, something like that. Call our function find sum, and if you've ever wanted to calculate, for example, 1 to 100, this function will do that in a flash. Let's print the output. And to review, we've created this variable. It's a long integer. We're using that to store the results from our find sum function. Find sum takes the low and the high value counts through that range and keeps track of the sum. And let's see if it works. And I do have a typo here. I'm missing a T. So we'll try that once more. And there we go. And it calculated that as 5,050. And just for fun, let's try another one. Let's go from 1 to 1,000. And there you see 500,500 would be the sum. So a little bit more helpful function than simply squaring a number. But the idea as you develop your skills is you'll find how convenient and easy it is to just visualize something that needs to be done, to put that something into a block of code and give it a name that's easy to recognize, and you can start to put together more complex programs that do interesting things, and just do it really a piece at a time. I hope you enjoyed this brief video and will have a chance to explore the concepts such as making your own functions and using for loops and writing output to the serial monitor. And although these concepts are basic, they are really fundamental to most programming projects, and you'll be able to do quite a bit with those concepts and using those in the context of the powerful Teensy audio library. So I do hope you enjoyed it.